Generators are a lot like electric motors, except they work in reverse. The rotor is made to move against the magnetic forces, creating electricity. Just one generator alone may use many tons of iron. The great strength of steel holds generators together, and it is also necessary for the entire rest of the grid, holding up power lines and making for strong antennas.
Hi, my name's Jaman. I'm a musician. The first thing I would talk about is how you can get a guitar to make sound, because if you strum it, it doesn't make any sound. And then with electricity, you can get something out of it.
So if we imagine that this table is the magnet in a guitar pickup, if you could see the magnetic field lines, they would come out and all around and up into the other pole of the magnet. Now the string will exist crossing through this field, and as it moves, it changes the way the field lines will conduct through it. And the coil around the magnet detects the change in flux as a current flowing through it. So what we have here is an old tube amplifier. Guitar amplifiers still rely on the same technology as this. Now this device uses quite a lot of iron in it. You see that there are actually 3 transformers. The biggest one here being the power transformer. This is going to take the 120 volts main current and step it down for all of the filaments, which heat up the tubes, which allow them to operate, and also step up the voltage to a couple hundred volts in order to drive the actual amplifying circuitry. So the last part of the audio chain is the speaker. So I'm going to go ahead and take a knife to this speaker and we'll find out what it actually looks like inside. This coil right here is the voice coil. This is where the current from the amplifier actually goes, and this creates its own magnetic field, which counteracts the magnetic field formed by the magnet back here. Now these 2 metal pieces, which you could see from the outside, but now you can very easily see the gap formed by them. These 2 iron pieces actually will conduct the magnetic field from the magnet and focus it right in here, which gives us a very, very high field intensity, which allows a little bit of current in there to cause a great deal of force on the cone.